So I've got a large trained neural net that is a policy network for Lunar Lander V3. I want to distill that network's weights into a smaller network policy. And it is a soft actor critic setup, so it's distributional outputs. So I might have to get clever with how I do this distillation. Loss function might be complicated. Maybe not. I might just be able to match the weights or match the outputs. Let's see. This. Hide screen. Okay. Just don't want people's names popping up on a video. Okay. We don't have Q functions after we've trained. Well, we kind of do, right? Like, we can do whatever they're doing. But I think they are doing afters.
Yeah, they're only used in training. So they only use it for like.
Yeah, because for DQNs, they actually use it during inference time, like test time.
Yeah, I was talking with Varun about this. Like if say you like trained some network, like when you actually like wanted to perform on something like say real, if you like decrease the entropy all the way down to 0, you know, or like the exploration.
Well, here's the thing: you won't be doing updates anymore. Well, you can.
Yeah.
Because soft actor critic can continually run during an episode. So, if you decrease the entropy and you keep running it in real life, it's going to continue to learn, but it's going to get less entropic, obviously. And so that's going to converge more to like doing one specific set of actions, having a less robust policy. You can actually hurt performance that way by making it forget how to do previous things. You do generally want an annealment strategy, though. Like when you're doing training, you want to bring the exploration down over time.
Yeah, that's the one thing I haven't done yet.
Yeah, you should train mostly to, I won't say convergence, but like at least like if your loss curve goes something like this, like stop here, and then because like you'll go out to here and you'll see it's kind of converging or slowing down a lot, and then you can bring the exploration down or up or whatever you want to do. Yeah, I'll probably bring exploration down.
Yeah, that's usually what it does.
It depends on the game, though. Like if you're playing something that has strategies that are not like relevant to the rest of the game, you might have to bring the exploration up at some points. But for rocketry, it shouldn't be that way. Three methods of policy distillation. We don't have Q functions in the actor network because they are argmaxing their Q function to figure out what the action should be for a DQN. But we don't do that. We actually have a policy network. It looks like they do the same thing in the student only. That's kind of cool. So they take DQN and train this thing with Q function. They feed episodes in to a replay memory and then do updates like we do, but they're updating this policy network that was never trained before. They save the outputs of the DQN, and then they use that to get this distillation loss and then do an update on the policy network. The input state and game label are used to get the predicted output. Okay, that's about what I'm doing. It's just like I'm not using DQN, so I don't need Q network stuff. So this should work. Everything on this right hand side. Let's say use Quebec Liveware. How would they do that? Don't use mean squared error. I wonder what the difference is. Let's see. Oh, that's crazy. 34%. So 95 for Quebec Liveware versus mean squared error. I was just going to use this. It looks like that's horrible. I'm going to have to inspect the outputs of the policy network I have because it's going to be distributional. It's funny, they actually get better performance on the Distill network. And they did on some games for the full network. Like decreased to 7%, and you actually improve performance. Huh, I wonder why. Okay, that's all there is. Let's do it. SAC model from SAC. Well, I think 3 does it. Use modular.
It works sometimes. This Lander, I don't know. I'm gonna try that entropy tuning like later on tonight, and,
Okay.
and try retraining it.
Are you showing the?
Yeah, I just did like this is the first time I've like tried like do it in the record mode. I've just been like labeling plots. Like sometimes it just veers off,
Right.
and it's veering off a lot right now. I don't know.
Wow. That's crazy. Just land on your knee.
Yeah. But yeah, it's like I don't know. It's really hard to like. Maybe it's just like this like reward function is just like really hard to get high or something. I mean, how
it should be the same.
what were you getting for yours?
2,
3 and 200.
250 sometimes.
Damn. Yeah, I'm not getting that at all.
So something's gonna be up with your training somewhere.
Yeah.
After I get this running, we'll take a look.
Yeah.
This Friday at the they have a colloquium talk by John Herschel. You ever heard of him? Football player.
Is that a football player?
I think he's NFL.
John Herschel.
Herschel.
Mm,
He's famous as a mathematician because he's like this black guy who does combinatorics and he plays football professionally.
yeah, I mean it's definitely an archetype.
Yeah.
It's cool.
I don't know how good his research is.
Yeah, I've never gone to like a colloquium before.
You didn't go with a.
Yeah, I did go to that one. Yeah,
They aren't usually like that. Exactly. One time, some guy came and brought poop from like animals in like amber casings, but
Yeah.
that was all the other weird colloquium. Usually, this is so boring, you can't even stand to keep your eyes open during it. All right, what's Plug come up with? An absolute mess. Hey.
Guten Tag.
I'm inviting 300 people.
Yeah, that's what you say too.
What? How many?
1,300 something.
Oh, yeah.
Where are you getting 1,300 from?
I'm in 21 to 20 clubs, so I invited all.
Oh, okay. Yeah. Get pizza, maybe.
You just, all of them come for the pizza. You just run out of it after like 5 people. All right. I just wrote all this code by hand. Just painstakingly time. I'm lying. I didn't do that.
Well,
This is cloth. So we're distilling networks. I got a trained soft actor critic based network. And it's big, and I want to be able to train a big network, like on a real rocket, or on a simulator rocket, and then
Do you know
distill.
why it's like Rue and I were talking about the standard deviation output and
Mhm.
why it's like innately like a log. Like they train it to like be a log of the standard deviation instead of just the standard deviation, and then they raise it to some exponent.
You're looking into stable baselines and seeing that?
Well, it's in this one. I've seen it like in like most implementations.
So I'm thinking stable baselines, right? Because I don't do anything like that. So I think when it does learn and you actually sample it to do predict, it's doing that, right? No, just for, well, yeah, for predict because it's standard deviation. So let's see. It's just for soft actor predict. You've seen it do that. I'm gonna put this in.
Yeah, I guess so. I mean, this is soft actor critic is the only one I've seen like output standard deviations.
and mean is not log.
No.
I don't understand why the mean isn't.
Yeah, I just saw it like pop up in the Claude code that you got as well.
Oh, okay. If I don't know, then Claude will tell me.
Yeah, I've just heard just like the basic like numerical stability. Like,
That's what you're doing for the reason of it.
yeah, but like I don't. They just always like throw that shit out there.
It's like that 10 to the minus 4 that people use in like MPC without any explanation.
Oh, yeah.
Yeah.
Numerical stability. They have to be positive. Okay, that's obvious. Well, one thing is you don't want huge. I think it has to do with the floating point precision. So you have a lot of precision near zero for floating point, but still it's limited. If you work in logarithm space and your standard deviations are enormous, the logarithm is going to be much smaller.
Yeah.
I think since you are using entropy, it makes a lot of sense because you want your standard deviations to be pretty big anyway, as big as you can get them.
Yeah, I just didn't know like why they didn't just like clip it or like take some absolute value instead of log.
So you will have, if you have absolute value, your gradients don't exactly work. They do say it prevents that. So clipping would work, but it's not going to work as nicely with gradients.
Yeah.
Log is also unbounded.
Yeah, we don't care about that. We just want the standard deviations never to be negative. So if you represent them as their logs, you can still move around in the whole floating point space. But then when you take exponent, you move back positive. It's just a domain reparameterization trick. And I imagine it like just is a better mapping onto floating point values that can be represented just for training. So you have more ability to converge to a good number in the long run.
And also put that natural log is computationally easy, so with like that precision.
Well, we're not actually computing it. You only end up computing the exponent. Because you represent, in the network, you actually keep the numbers that are the logs, but you don't do a log calculation. But when you actually want to go and do a prediction, you need to compute exp of whatever the thing is, e to the power of it. So you never actually compute log. Let's see. And then they do clip it.
Yeah.
So one thing is like, if your log doubles, if you multiply it, but let's see, if you add 1 to your log, that's going to essentially raise the power, the order of magnitude of the actual standard deviation. And usually you want to be moving the standard, like orders of magnitude rather than like just some arbitrary number. So it just makes sense to do this.
Yeah. Yes.
Okay. So this is the non-distilled version. This is the distilled version. Where do I specify the sizes? Here. So policy, hidden sizes.
Yeah, what size did you train on? Was it just 6 like?
This.
Oh, you did 250.
Yeah. 3 hidden layers of 256 each. Are you using something smaller for yours?
I mean, I tried two layers with 256 and 2 with 64, but I haven't tried 3.
I think 256 and 2 layers should do okay. But of course, it'll be less performance at the convergence.
Yeah.
Just because it's not as big. But it still should get up to like 100 reward every time.
So you were able to run this? The solution?
Oh, it's already trained, yeah.
Okay.
Yeah, I've got those weights saved here. This one does not work at all. Yep. Okay.
You have a dot zip, dot zip.
Right. I don't know where it's putting in the extra .zip. But
Yeah.
it just doesn't know what my directory structure is. Where is this happening?
it's
actually sampling the distribution that the policy network outputs, the actor network. Oops. I don't feel like this one's gonna work.
yeah.
Same as the start, okay.
Where's this unpacking happening?
Sorry?
Where's this unpacking happening?
It was telling me a bit ago that I think it removed all the brands.
Line 19.
Yeah, that's right. But it's on this. I have to dig through PyTorch's internals to figure out what's even going on there. Oh, there we go.
What did it change?
So now I'm not actually extracting the mean and standard deviation that the teacher network is outputting. I'm just I'm extracting the samples themselves. So the actor network will output a mean and standard deviation, then I sample it, and then
These performances are just like rewards for some.
there's no rewards at any point here. I'm making up rewards by coming up with this Kovac-Leibler divergence between the Gaussian distributions. And I can use the samples instead of actually having the mean and standard deviation. Let's see, that actually seemed like it worked. Oh, that's cool. Look how fast that training. I already get 100 reward. So it just does sampling and uses the sample instead of training against the mean and standard deviation now, I think.
Like the big picture, like what is the student network, student policy network like interacting with? You said like its reward functions kind of like Kovac, Leibler.
Yeah, so pull the camera out. So I've got 6 neural networks. SAC teacher is what I trained the first time. And it is a policy network. Pi. It has weights theta. And I've got these Q networks. So Q1, and that's feeding parameters V1. You got Q2, another Q network that's feeding parameters Q2 or V2. You got Q1 target, which is feeding the parameters V1 target. And then similarly for Q2 target. Target. And for the purpose of what I'm doing now, I have a student at work. This is pi, we'll call it pi tilde, and its parameters, we'll call them theta tilde. So this is the actor. This is the critic stuff. And I trained all this together, and I've kept all this, but I'm not using it. Okay. I'm only using this. So what I do now is I take the distillation setup is the following. I have two networks, the teacher, and I've got the student. I run episodes. Let's see, so let's take the environment, put it in here. Put it down in the room.
So you want to turn the lights on for this?
Yeah, sure. All right, so I've got an environment. The environment starts, I got the an action for you next time. So what I do is I feed the state into there. I feed the state into here. Let me write that down, actually. See this way. So this is the state. It goes into both. They each spit out an action, which is it's a linear combination of the four actions I can do. So I can output a particular amount of thrust to the right, roll, particular amount of thrust to the left, particular amount of forward thrust. I think that's actually a 3. And so this guy does that. He outputs an action. A, and this guy's going to output an action A tilde. And actually, these are Gaussian distributions that they directly output and sample those distributions. So really, I should be saying, this isn't A. This is outputting pi of S, pi theta of S. And then this is going to output pi tilde theta tilde S. And these are going to be pairs of means and standard deviations, and these are the same. Now they'll be different, so the weights are different, and the sizes of the null numbers are different. But then I sample these guys to get A and A tilde, which are linear combinations of the three actions. So I get this. Let's do like a pen. Now, this I use and feed it back to the environment, the next step. I do not collect the reward from the environment. That's irrelevant. What I'm using for a reward function or a cost function instead is one of two things. I can compare the actions, and I can look at linear combinations and just do mean standard error across the three components. Or I can look at these guys and compute a collaborative divergence between probability distributions. And that's what I do. So I actually take these. And get KL. So the distance between the two. and then I feed that in as a cost function for this guy. And I will update this. So this should be here. So I was going to miss that loss. That answer? Yeah, sure. So now I get 133 for my performance. It seems so. I think it's doing another episode at the end, or another collection of episodes at the end, and it takes the average reward across those episodes and see those. So it should be actually running the student network and having it, evaluating its performance. I'm going to try turning up the number of training examples that I use. So I was using 50,000 before, so that would be 5E, 4 zeros. So 5E4. So I'm going to go up to 1E, 3E5 instead.
Training example to the number of episodes.
Number of samples.
Yeah, I saw that like you should keep it around like 1 million, like a replay. I saw like if someone was talking about on Reddit that you have like performance issues if it's like 100K or something.
Yeah. So this is it's effectively a replay buffer. I don't know how this is decided to do the selection for epochs, but I think what it's doing is it's one epoch consists of running over all the training examples and then doing a batch gradient descent update.
Yeah. Yeah, I was running into some problems on the batch. I didn't know how to like directly code it because you could take some like end batch samples from like your replay buffer. I didn't but there's like an innate function that can calculate like say your like MSE. You can't. I don't know. Like originally I was doing that, but I was getting into like dimension issues because it was just just trying to like compare like one output Y to like say some 64 of the Qs, or your Q, your Q bases. So I tried to do it individually, but then like Claude was telling me that like that could run into like numerical instability, I don't know.
Okay. Learning rate. Four. I want all these to be specified at the top as constants. Seed should not be 42. Let's do 0. And save interval. Epochs.
So distillation is running on the replay buffer, not the actual environment.
So they don't technically call it a replay buffer. I just collect however many training examples, and then if I run a callback library divergence across all the training examples, and then I do like a mean squared error or something, then that constitutes one epoch. So I calculate the gradient, take the mean squared gradient for the whole thing.
So you don't have many batches?
No. I could, but I have the luxury of efficiently computing the whole thing because I'm saving all the training examples. I could redo this where I generate new episodes over time. But since I'm sampling, I'm not using the student network, which is learning as I train to generate the episodes. I'm not actually changing anything about the episodes, so I might as well just save a bunch. You could do mini batches if you wanted some like regularization, but you can also just increase your training examples. Oh, okay, I'm wrong. It is doing batch size. So it is mini batches. I could increase batch size to be all the training examples. So that's 2 to the power of, what was it? 1, 2, 3, 4, 5, 6, 7, 8. The 256. Let's do 1024. Save it. These things I don't need to change. Everything else is a constant at the top. Okay, we're good. Now I want it to also print, because like I get good student performance on the 5th epoch, so like I'm wondering if it even like.
How's it evaluating the teacher performance?
It looks at, I think it's running. I mean, I don't want to say.
You said it's running an episode at the end?
It should be. Yeah, so it's actually generating a new episode that the teacher's running. And then it does the same thing for the student network. It just generates a new episode for that. And then let's see, eval episodes. Let's do eval episodes. To 532. And then I want to do one more thing. Make there be an eval of the uninitialized, or the student and teacher network at, before doing any student network training at all, not just after the first eval interval epochs. Good. Then I need to delete the existing student.
No.
What broke? Mine 10.
I thought it was the same person.
Okay, that's not even there. Collect teacher samples.
I think you forgot to zoom back in.
No, it's zoomed in. Yeah, I did it when I turned the light off. Where's it erroring? No, that's not true. Line 10's up here. Float object can't be interpreted as an integer. Oh, I see. Okay. So this should be down here. I should be doing.
It should be like smart enough. Whatever interpreter they wrote, it should be like smart enough to catch the setter, like try doing the typecast. They don't have it.
Well, I didn't. Claude didn't write this. I put the constants in, and then I started specifying them as exponentials. So.
But even in like Python, like the interpreter should itself like try to typecast.
No, that's really bad. You don't want to do that.
Yeah, I mean, like if you put the warning out, like you should at least try.
No. Banks run on Python. Like you don't want that to happen.
Yeah, or there should be like a configuration where you can configure this.
It's better to just throw an error. Okay, this should hopefully work all right. There we go. Okay.
What is this tech?
So I'm building this training database.
Is this running episodes?
Yeah, with the pre-trained teacher network.
So this is not technically a replay buffer.
No, in distillation, you really don't have a replay buffer. You just have like a data set proper. This is actually supervised learning, not reinforcement learning. I like so the way it's doing this progress bar is with this library called TQD.
Oh yeah.
So if you guys haven't seen that before, this is like super useful.
You just put it in the for statement
Yep.
and then it just does it.
Yep. So, yeah, the way they call it is like literally this. You just put it around the range, you put a description, and you get this. Yeah, super nice.
Yeah. I think you also get time estimate.
Yeah. See?
Yeah.
So it's saying there's 38 seconds left. Tells you how many iterations you're getting per second. Bless you.
That's interesting. I've never used TQTM before.
Yeah, anytime you're working with PyTorch or TensorFlow or anything, or JAX, this is usually what people think to use. It just works out of the box. Almost done.
I have a class.
Okay.
Well, we can at least like 3 of us can do the attendance.
Oh, I don't know how to do all that.
I think you can like self-report. We don't pen. You just
Yeah, I will try to just do the accessing through Discord, I guess.
Oh, that's nice. Okay, so it starts at negative 238 and then get negative 199, 213, so it's not performing well yet.
It didn't start with negative last time, right?
I think I was using a slightly pre-trained network.
Okay.
I'm actually not sure why it was performing so well last time.
It was not supposed to.
It was really fast. I don't know how it went so quickly. Because this one's not seeming to improve very much. The loss isn't improving. There it goes. A little bit.
Yeah.
Well, not the loss, but the performance.
Okay, that's oscillating back and forth.
Yeah. Maybe.
wonder why the loss is like exact.
Yeah. There's some different episodes too. So it should be at least like jumping up and down.
It is jumping up and down.
Minimally.
Yeah.
I would expect it would be wildly different every time. Something's wrong. And I wonder why it worked before. Okay, there we go. Oh,
Did you set it correct?
what do you mean?
It's like already like 1/10 streaming, but the moving at window average like certain performance, it's kind of like the same.
Right. I mean, it's just not learning anything.
Yeah.
Because before I was getting like 130 every time for the student performance, which makes no sense. I have a lot more training examples, but that shouldn't hurt. Should help. Learning rate. Oh, this is the problem. The learning rate is 0.
Oh my
I'm an idiot.
That's funny. Oh, that's good. This way.
Oh, fuck. No. I probably just created 100 files. What the? How did it start this?
What?
What's going on? Oh, it's because OBS, like observation. How the hell is it calling a file like that? I'm so confused.
What just happened?
Oh, it's because it's running it in the shell, so it thinks the OBS lines, like here, are trying to start OBS.
Oh, I see what happened here. Kind of like pass the whole code in the shell.
Yeah. Am I missing anything? I didn't think it created anything else. No, we're good. Okay. There we go.
The same.
That's crazy. I should save the teacher samples, so I don't have to make new ones every time. So it takes like 2 minutes. Well, this is running on.
Yeah, PLC has.
Yeah. It started already.
Shit, dude.
I think I'm doing a little like 5 minutes.
Yeah.
They started with this.
I guess.
It's gonna be the second session on this.
Yeah. I mean, I enjoyed it when I took it, but looking back, it's just like, damn. I think stronger academic programs like incentivize like learning shit like that a lot more. You know, like
Yeah, but like I think they incentivize like actually using it, not just like learning them how.
maybe.
Here it is like you only like see it from the outside.
Yeah, that
You
is
never
true.
touch it. Like
Yeah, they probably have like actual labs where you have to do stuff with it.
try to like modify shit, something like that. Here there's like no reference.
Yeah, if you want to meet up after class, you can like maybe if you're free, you can.
Today I'm not free, bro.
That's cool.
Okay, there you go.
-2 point, I think it's max that.
There you go. So your performance is already mounted
Oh my god.
on these setting.
Val.
Yeah.
That's crazy.
What did it stop?
It might just take a while. There you go. I mean, you can run it for 1,000 bucks.
Lost looks good.
It's gonna have some variance.
Yeah.
Because the environment's gonna change. Okay, it does. We actually, I don't know if you were here when we started looking, but they deep dive into paper where they talk about distilling leak events, like on a tolerate game and stuff. And you have discrete hash spaces there, so you can't do things that you could with SAC.
Yeah.
It's still improving. But they actually showed that if you distill the network to 7% of its original size, sometimes you'll actually improve performance without any additional training. Yeah. Yeah. So I guess
Yeah, that right.
This is actually really good. I expected it to be so fast. That's fine. It's gonna crash sometimes.
Why 7%?
Well, they did a bunch of different sizes. They did one that was 25%, 7%. I think probably they should try it at like 6 to 5%. If I should work as well.
This is, did that have something to do with the fact that that's discretized action spaces?
It's just whatever number is as small as you can improve performance with. And then they did one at like 2%, and it decreased in performance, but it's still really good.
And what if you like keep doing that like 2%, 3%?
Oh, no. I would expect if you distill a distill, it's going to work well. I mean, it might, but you'll obviously it's going to be awesome. I mean, it's almost salt again. Oh, that's salt. Good drifting. Yeah.
But why is it oscillating micro?
It's going to. It's just a smaller network, so it's going to be less robust. And it's also not seeing as much training data as the teacher network is offering training, so it generalizes some too.
That's good. At every eval interval, are you like generating new episodes?
Yeah, so epochs are pulling from that database of 300,000 sample times. But so this each one is 1,024 time steps. And I think they're from random places in the 300,000. And then when we do this, we run, I believe, 32 episodes. And we average them for that. And that's new episodes, not the data set.
Yeah, I'm hoping it's the new ones.
Right. Yeah, so this is, you can think of this like a validation.
Yeah. And that's also calculated just like this, right? We go back later.
No, those are the actual rewards from the environment. So 200 is when you solve it. I mean, I never saw with the network was small, I never saw this kind of performance. I turned directly, so actually distillation is really good.
You're off the roll.
Maybe you can try like distilling it to like a not so small size first, and then like distilling from that.
It's just the point. It's gonna be worse.
Because it's kind of like that philosophy, like when you initialize like Xavier, when you do like Xavier initialization, you have like smoother flow through the layers. It's kind of like that philosophy.
So you're thinking, because the dynamics of the teacher model might be too complicated for a small network to learn.
Yeah.
So it'd be better to progressively make it. Yeah, that's possible. The thing is, with performance, you might think like, okay, one big network takes a long time to get the samples from because it's a lot of inference compute required. But since you're pre-computing the entire data set, that part doesn't matter. After the initial collection and training, so then you can use second, and you can always do. Like you could literally like make like a 100 million training sample database from a huge network and save it, and then literally toss your network in the trash. You don't ever use it again. Also, what's kind of annoying is that these are different episodes. They're not the same initial conditions.
Yeah.
So the performances aren't apples to apples.
Yeah.
But that's okay. Really, I should just be only evaluating student performance every time. But it's not much slower, so.
I think like seeing teachers' performance also like helps. Because like you can see that if teacher also perform bad, then you cannot expect it.
Yeah, we're not changing the teacher performance.
Yeah. Because there has been like instances where the teacher's performance was not too far away from the students.
You should actually expect the student to outperform the teacher sometimes.
But you're gonna have 7%. What's the model? Oh, it's 64 and 64 layers.
Yeah, and the original was 260, 66. Pretty good though. I mean, it seems like it converged. I should honestly be plotting like a chart. The loss is not, it's still improving. So I guess this is the metric we should really be eyeballing.
Yeah, lowest rank.
And it is gradually going down. It seems like, yeah, it's a new best. 191. A recent best anyway. I think we're getting 200 at some point.
What is it? I think you should like reduce the learning rate.
Atom is going to automatically redo that.
That's also true.
Yeah, with Atom, you don't have to worry about that too much. I would just use 3 equal before for everything. Now, in practice, if I were training a huge network, it wouldn't matter. And what I would do is I would do short training runs, and I would do a grid search of all the possible types of things like that, and figure out what works best. But yeah, we're still getting lots of improvement. I should probably plot more digits, but
And one thing I want to try, my like sounds dumb, but try like reducing the number of neurons per layer in the second layer and like split it into like 2 layers. Like have 3 layers, but
just force them to connect to the 0.
like instead of having 64 neurons in the last layer, have like 32.
Side by side.
Yeah.
That will work, but it's the same thing as just setting a bunch of weights to 0.
I think that will like have better learnability
Why?
or like generalizability. I don't know, it's like hard to explain intuition. Like, let's see.
It's going to cut the computational cost in half. You have half as many weights. You can do it.
Yeah.
But, I mean, I don't want to play with architecture too much. It's just,
But there's features you cannot build in like just 2 layers. Or like there's abstraction. There's a certain abstraction level that you need to have, which will only come from like number of layers.
well, think of this. If I have 2 layers that are 4 each, let's say 3 inputs and 3 outputs, then what do our connections look like in a fully connected? Well, it's going to be like this. And so the next one is what you're talking about. So I would have, Jesus. This is why mathematicians have algebra.
Yeah. Yeah. It's so funny.
Okay. So you're suggesting force the structure into this part, which is to do this. Right.
No.
Or this. I'm stupid.
What I'm saying, no, I'm saying like have 3 layers instead of 2.
Yeah.
Fully connected 3 layers.
Oh, and do half size?
Yeah.
Yeah. Good. And then you would have less weights. That's true.
I think because like number of layers is more
It is.
sensitive,
But
but more important.
I've seen people solve this with just 2 layers. And I think the default soft diacritic and stable baselines is like 256 by 256. My loss isn't improving anymore, so
Yeah, it is improving.
So I'm gonna see how it flies now.
I have to leave.
Oh, no, it's improving. It's new best. Student. Still improving. It's crazy how little code I actually have to write anymore.
Yeah. Because you vibed out.
I didn't really write any of this. Just had constants at the top. Have you seen the RWKB models? Colors. They're pretty cool. So they're made by people in Discord, and there's no like university responsible for it. I think Jack Dorsey might be funding this one in particular. No, I'm wrong. He has another company making videos that has nothing to do with this. But yeah, you can just like join the Discord and do research with them. And they've come up with this new replacement for attention models. So they don't have attention. They have infinite context links because they're actually recurrent neural networks. And they outperform like llama models and stuff like that. It's much more efficient. Everything's open source.
Check them out.
The design's much more complicated.
Yeah.
Almost there. Cool. Student outperform the teacher. I don't understand how it's doing in the Quebec library.
Yeah.
So this is in the training loop in main. Loads teacher model. And the environment is SP3 wraps that. Initialize the optimizer, Atom, resume, collect the samples, and simple. Store the states and actions from the teacher. It's weird because this wants teacher mean and teacher standard deviation. Am I even doing those? Batch actions. Oh, it's like stubbing in fake standard deviations. Just ones for each of them. So it's definitely not going to perform as well at the end. I think it's just going to learn to have standard deviations of 1 every time. Let's Okay. That works so far. Let's see how it looks. Pretty. Oh, there we go. Nice. It's a bit hard landing, but it's still clearly learning to fly, which is kind of funny because I never actually trained it on the environment. It's so bad. So let's update this. Kill the checkpoint. Change my brands. Smaller batch size. Teacher needs. Where's it populating that? Teacher needs. Teacher samples. I just started training that a few seconds ago. It works much better if you actually use the right Kale divergence. Still crashes. But I can keep training, and I made my batch size smaller, so that is not that good. And then I'll increase we'll do what Varun said. Or make the size different. Way faster. Like 10 epochs per second. Look how cheap these things are. I get like 2 weeks worth of the cost of one monster at the vending machines here.
Yeah, dude, the monster is
$3.75, something like that.
insanity.
When I first started going here, I'd buy like 3 of them a day.
Yeah, 3 is
Blowing
crazy.
money.
The only time like I went like that was just like during hackathons. I just like forget how much caffeine I was consuming.
I broke my limit one time when my dad gave me this hazelnut coffee he made. He like way over concentrated it, and I got like Tourette's tics
Yeah.
because it was so strong,
Yeah.
and it would make my neck do this, and it hurt so bad. I was like, I would move my head for a week. I thought I was gonna die.
That's kind of crazy, actually.
But after that, I just not a strong responder to caffeine anymore. So I have made it save the teacher samples. So hopefully that works.
Yeah.
And then I can just keep running on a big data set. Because it takes about 3 minutes to generate the samples now. The training has gone up like 100 times as fast as it was. I don't know why. It's so quick now. And I get consistently 200 plus on my student performance. The nice thing is you can save your teacher samples and then be using different student network architectures and try different things.
Yeah.
It's quick to experiment that way. Just a little while longer. Seems like it's consistently winning. Actually did better than the teacher that time, so we're getting close. After about a third of the way through training, maybe it starts winning. After 1,000 epochs. I'm out at 900, I think. Or no, what? 879. So right now. There we go. Come on, get something good. Oh, that's horrible.
What the fuck, yo? God damn, motherfucker. Fuck. This is so shit. Where are you going, bro?
Okay, so. And that's good. Let's see how it works. Awesome. Somewhat. I mean, it doesn't smack into the ground anymore. I got 179 anyway. It's working about as well as the teacher did. And this is really tiny. It's 432 neuron layers stacked in front. Yeah, that's really nice. Oh, okay. All right. I'm going to try it on a smaller one. But it's everything. Once Varun gets the sim done, we'll try to get something to work with that, but I don't really know what else to do right now until then.
Yeah, I mean, I got a couple like just projects on me right now. I also took up the CFD, but like, yeah, not gonna know too much. But I'll let y'all know about SAC. I know there's a definite difference in like just the actions that it's choosing.
Like when you watch this, you can tell
Yeah.
it feels different from PPO.
Yeah, well, no, I'm just talking about mine. Like,
Oh, I see.
mine is like from start. It's just all like shooting all of them. You know, it's just like panicking, trying to like adjust instead of just letting it drop.
Yeah, it does seem right. You mean it's just like it kind of flies off to the side or something, or it like starts tilting really quick?
Yeah, I mean, because it's just like activating all of them like kind of all the time.
Seems like almost random performance.
Yeah, I mean, I don't know. I'll do some more debugging. Hopefully it goes somewhere. But I'll catch you later. Appreciate the lecture.
Yeah. See you around. Hey, do you have your code on GitHub? I can look at it.
I mean, I'll like repost it.
Okay, just send me a link. I'll check it out. All right. So I'm going to do one more run with a smaller network, maybe 316 neuron layers. And it should train a lot faster. Might not perform well, but we'll see. So let me go ahead and save this. So it should be this one. Oops. Let me do that. 16, 16, 16. And then let's kill the network. And we'll keep our training samples as they are. Really bad performance. Good. Loss is steadily decreasing. Iteration speed is not that fast. Compared to before, I was getting 5 point something per second. about 10, 15 minutes. Should be good. It's kind of interesting how many epochs we need seems to increase for smaller networks. To get the same performance. Oh, that's cool. It's not even running the feature performance anymore that I see. Oh, it is. Okay, it's just to the right. But I'm assuming I can get comparable performance in this tiny network to what I was getting the bigger one, the 32 by 32 by 32 by 32, the 32 layers. I'm assuming I can get 200 plus on the reward at the end of training, but letting converge. So under that assumption, I should be able to get like a curve of what the optimal training time is and do some kind of grid search on improvement rates per unit time or whatever. Or, well, my real target is like getting a network that's small enough to run on the rocket. So presumably I have the architecture determined by the characteristics of the rocket as well as reshaping, right? So that it trains as quickly as possible. Or rather, it gets the best performance possible. So kind of as deep as I can get it while still having a reasonable width per layer. Loss is definitely not decreasing anywhere near as quickly as it was before. My performance is really bad so far. So let's see. In 100 more epochs, I'll get another eval. So about 30 seconds. Full improvement from last time, it's still really poor. So it seems like this is definitely not large enough to perform as well as we need. And I wonder if that's a function of the soft actor outputs rather than having deterministic outputs. Again, about 25 seconds, I should have another eval run. If it doesn't improve much, I'm not going to continue training, otherwise I will. Seconds. Steady decrease in the loss, though. I mean, it's almost, what was that? Went down to 0.3 first time, and another 0.15, and then another 0.8. And now it's just barely decreasing. So performance isn't above what it was on the second eval, so I'm just going to stop it. And then we'll go and maybe try 64. No, Maybe 32 can do okay. It might be also that my learning rate was too large. Unlikely, but it's possible. Let's go ahead and kill that checkpoint. Quick decrease in loss. Another thing I might try to do is just increase the epoch size a lot in batch cells. Decent. So if I give this another 10 minutes and it works well at the end of training, I'll see those weights and take a little deal. And call it quits. Loss seems to like plateauing. But steady improvements. Good performance. Only 2 minutes in. Or worse. Starting to plateau a little more. Slower improvements. Distillation speed's improving. I wonder what's causing that. Where's performance? I wonder how R1 was distilled. Okay, 800,000 samples from R1. SFT, supervised fine tuning. So that's what I want. I don't really describe it here. This is not what I'm looking for. crazy that the O1 mini is beaten by a 14 billion parameter reasoner. This is what I was thinking about logits. You just distill with Copic Labler. This doesn't explain the technicalities. This doesn't seem true. You probably need to save the logits. Okay, so this is what they're doing. They're doing KL divergence for the logits. But you can also just do cross entropy loss. So you're only looking at the actual output token. All right, correct class is predicted probability with class is the output token from the teacher model. Interesting. Okay. All right. So this finished. How are we looking? Decent first landing. Decent second. Probably 200 plus. I have to guess. No. Okay. Definitely. Oh, nope. Never mind. Okay. Crash. Safe landing. Good landing. Really good landing. Crash. Good. Good. I mean, this looks like I just stopped training a little bit early. That one's really strange. Wow. I wonder if I wanted to fine tune this, what would I use? I, of course, can use just straight up reinforce. Well, not exactly, right? Like, you've got the distribution outputs for the actor model, for the student model, so it's not exactly clear what the cost function is going to be. Like a soft policy gradient sort of deal, is that a thing? I don't have, you know what? I can use the Q networks. I can still use the Q networks from the teacher model. And just shove these weights in for the policy network, and then I can fine tune that way. I mean, it's a lot of extra code I'd have to write, but in principle, it's the right thing to do, I would think. Right, so I would use this to get pretty decent performance at the start, like 150 or so, and once I get that, I can then do the fine tuning with rewards on the student network. Yeah, I'm fairly happy with this performance. It does crash a lot, but nevertheless, it's landing in the right spot. Generally learn the right policy, just a little bit off in some ways. Yeah, it's really clean. I like it. Sometimes it's catastrophic failure, but it looks good. That one's horrible. I think it might be because so it shouldn't be able to recover from catastrophic failures because the large network is not experiencing those in the training set. So never am I getting any recovery scenarios really, like from this. There's no situation in the training set where the large network really has to do a large recovery. I mean, there might be, but there's very few of them if there are any. So it's to be expected that that's going to kind of happen most of the time. That was crazy. You might think, like, should I be doing regularization during training of the student network? But I don't think it's necessarily the right idea to be doing so because you're already getting a lot of regularization by having simply a smaller network. So I think the only real answer here is to just do fine tuning on the rewards, like do extra reinforcement learning at the end for the student network. And then it should give you comparable performance to the teacher network, if not better. Because, I mean, like, given the same number of, given the infinite horizon training time on rewards only, the teacher is going to work better. But like, no matter what, even if you do distillation at the start, yeah, this seems like a viable strategy for our rockets. Just make a network big enough to do whatever you want. Get the performance characteristics you want and then distill it and then fine tune. Because I wouldn't trust this on a real rocket just because it's not able to recover from catastrophic situations. Maybe I can change these numbers a little. Nothing to train on. Let's do this. Much better iterations per second now. Incredibly fast. My loss has improved a lot since I was thinking about it last time. But it does seem like it sort of like, oh, it improved. Still improving. Good. Iteration speed is slowed. I wonder if it's storing things in memory that are causing it to slow down a lot. That's fast. Yeah, it's nice that you can just save everything and keep training forever until you get the loss as low as you want it, basically. We could just run this all the time. And it's not expensive because you just cache the outputs from the teacher network, so you don't even have to have a supercomputer to do this. no matter how big your teacher network is. You can even save training examples from during training of the teacher network. So you don't even have to do anything separate from your normal training stuff. It's kind of cool. Come on, improve the loss. You can do it. Plateaus for a long time now. Good performance. Really good. Wow. Okay. Is it just seeding? Is that all? Okay, it's using random for the shuffling. At least NumPy is random. I don't know about the regular Python random. That performance was worse. But the loss got a lot better. Better. Even better. Let's see. Would it decrease the size to split into 316 layers for the last layer? So 32, 16, 16, 16? wonder. It's hard to know. Huge plateau. Not much loss improvement that time. Might be converging. There we go. That's something. The performance is really great now. Even if the loss isn't improving quickly, the performance is way, way up. Consistently much higher. Five minutes maybe. Slowed down a lot. I wonder what the architecture is. ReLU on each linear. Linear layers for the last. Oh, interesting. Really simple. doesn't clip. Interesting. Good performance every time. The only non-winning performance was here a while ago. Quite slow loss improvement now, though. But we only got like 3 minutes left, so it's all right. Really bad performance that time. Better, much better, actually better than the teacher. A 1,000 episodes, 3 more evals, about 2 minutes left. Assuming my iteration speed stays up. Still don't know why I'm only done that one time. Yep, I had to feel it. I don't like how Claude likes to put an extra space at the end of each of these lines. Performance is worse each time now. We're very close to done. I realize I'm kind of messy with the unindents, but it's all right. And we're done. Oh my God. That's a lot to go through. Could keep trying to train a little more, but it's getting a bit gratuitous at this point. So let's just take a look. Alrighty, that feels more stable. Definitely more stable there. Yeah, iffy. Good. Good. Catches itself. Really good. So the landings are just too hard. But other than that, I'm pretty happy. 285, that's crazy. Really good stopping. Yeah, it's consistently winning. I'm pretty happy with this. Just a little reinforcement learning, fine tuning at the end would do the trick. This was pretty successful, actually. Yeah, okay. I'm happy. Good stuff. All right. Let's go ahead and end it. And this should be the last reinforcement learning session that we do, unless we get new people, until we get the simulation software running, the Julia simulation. And when we get that running, I can actually start training the rocket, and we'll start doing sim to real experiments. And we'll have a 3D simulation going, and so we'll be doing adversarial training of the wind model, which causes force vectors to be applied in an adversarial fashion to the rocket so that the controller network has a hard time controlling. We'll just give the inverse or the negative of the rewards that the rocket gets, the rocket controller gets to the wind model so that it'll learn to make it perform poorly, and then also feed some kind of energy minimization reward to the wind model so that it tries to make the minimal disruptions that can mess up the rocket's flight. And we'll do this tiered training regime where we train without the wind model and then introduce the wind model with large energy minimization rewards or penalty, and then decrease that energy minimization penalty over time. And we'll see how that goes. And do sim to real, and hopefully everything works out just fine. So that's it.